I'm joined today by Hugh Imberson, CTO of StorReduce, and David Wartell, Executive Vice President of IDT Telecom. Before we get to them, I want to talk a little bit about what our customers tell AWS. We're going to learn a lot about how StorReduce works. We're going to learn how IDT uses it. We're going to see a live demo, and we'll have a great chance for questions. But to set the stage, when we talk about backups on-prem, we speak about them very differently than when we speak about them in the cloud. The things that people tend to give concern for on-prem are different than in the cloud, and here's how. When we ask our customers what their challenges are on-prem, storage, backup, primary, you name it, we get pretty much three very concrete answers. First, there's the cost component, CapEx versus OpEx. Second, there's the deployment component, how you have to sort of be beholden to other people's inventory. You can't just deploy things, in a one-click manner the way you can in the cloud. Somebody actually has to plan it out. There's a supply chain component there. There's shipping. There's rack and stack. There's integration with your data center architecture. And then there's the repeatability component. Most customers don't deploy things in the sorts of volumes that would inspire them to put down repeatable processes that are totally failure-proof, which makes compliance somewhat of a doozy. And when I say that, what I mean is, if you look at gear that's been deployed over generations of employees or over generations of projects, it's really common that they were all deployed in a slightly different way, and that makes auditing somewhat of a challenge. So our answer to that is that what we would like for customers is we'd like for them to get all the benefits of being able to deploy things in the cloud, but still get the control part and the choice part. And so we offer a set of services, underlying services, our building blocks that customers are always free to use. But we also have gaps very frequently between what those services can provide and what customers need. So for example, what StorReduce does isn't done natively by any of our services. And so that's where what we call the partner ecosystem comes in. And the partner ecosystem applies, that partner word is very special. It applies to what we call the APN, or the Amazon Partner Network. So the Amazon Partner Network is, as it sounds, a network of partners. But there's two kinds of partners. There's consulting partners, and there's technology partners. So StorReduce is a technology partner. And they're actually one of my favorite technology partners because they follow that age-old Unix philosophy of do one thing and do it well. And so, when you look at deploying an APN technology partner, it should meet all of these criteria that you see on the screen. It should be really easy to deploy, which StorReduce is. It should give you the ability to put anything in there and have it processed, in the way that you expect. It should give you the ability to persist the data in the cloud, which it does. It should be highly available and scale out, which it does. It should give you utility pricing, that OpEx model, which it does. And lastly, you ought to be able to set policies in the same way that you can set them on things like S3. You ought to be able to set similar policies with things like StorReduce. So when we work with our partners, we work very closely with them. AWS and StorReduce have been working together for over 2 years now, from sort of its instantiation in the cloud. We've had very good dialogues and collaboration. You can see it on their blogs. You can see it in the product releases, that this is a product that was really designed for the cloud, and it was a product that was designed for users who are going to have the needs of a cloud user, while still managing to cover everything that these on-premises solutions do. So what are the underlying services that we'll probably touch on today? What are we really utilizing here? Well, everybody knows about Amazon S3. If you've heard of Amazon Web Services, usually you've heard of EC2 or S3. So it was one of our first services. It wasn't the first service, but it was one of our first services. It's sort of the Swiss Army knife of cloud storage. The semantics of how you use it are very simple. You put stuff in, you get stuff out. Now, there are more nuanced versions of that, but in a nutshell, that's it. And we have different storage classes for different pricing tiers and some slightly different usage models. But at the end of the day, it's a huge place that you don't have to pre-provision storage for and put stuff in there. And so when people integrate with the cloud for storing data, it's very often the case that they will first integrate with S3 because it's such low-hanging fruit. Now, alongside of that, another object-based protocol is Glacier. Now, Glacier is designed for cold archive. So the rule of thumb there is, if it was on tape before, Glacier is a great place for it. If it was not on tape, don't put it on Glacier. Now, why is that? It has to do with what we call the recall semantics of how you retrieve data from Glacier. It wasn't designed to give you the sorts of responsiveness that S3 does or a disk does. It is a very unique service in that regard. The other things that you'll see today are EC2 instances. When you talk about putting a workload in the cloud, you kind of have two choices, right? You can go the serverless route, which is I'm going to create a new application, and it's going to be completely infrastructureless. It's going to be integrated with all the AWS services, and I'm not going to have anything that runs with what we would call persistent state, on a machine. And then another way to do it is to say, well, I've got a workload, maybe it's a virtual machine, or maybe it's an application that I don't control, and I want to run it in the cloud, and that's going to end up on Amazon EC2. Now, when it comes to Amazon EC2, it's not just a place for customers to run their workload, it's also a place where partners often run their workload. So when we talk about a scale out cluster of a partner product like StorReduce, those are actually running, Amazon EC2 instances. And so that's another service that you'll see demonstrated today. So if you were just to go into the Amazon console and say, I want to launch a machine, that's going to be an Amazon EC2 instance. Now, along with that instance, sometimes you have local storage, what used to be called ephemeral storage. The proper name for that is an instance store. You also got a persistent block store, EBS, which is sort of you can think about it as the system disk or the root volume of an Amazon EC2 instance. And then we have some other storage services as well. We have EFS. We have some products on-prem that are sort of helping you get data into the cloud, like the AWS Snowball. We have network connectivity components like Direct Connect. But by and large, the things that you'll be hearing about today are touching on Amazon EC2 and Amazon S3. Now, one of the things that people come to the cloud expecting is everybody says, well, it should be, totally secure, and it should be immediately available, infinitely scalable, and free. And you kind of got to pick some of those. You can't really get all of them. You can do free tier, but you can't have a lot of it, right? You can have a huge amount, but it's not going to be free. You can plan your infrastructure in such a way that you can scale out infinitely, but it does take some forethought. Not all applications, easily render themselves to removing state from them. And then when it comes to security, that's what we call a shared responsibility model. So we have a lot of tools, a lot of great tools to help customers bring the kind of transparency and insight into their environment that they had on-prem with equipment that was physical. If you look at an environment on-prem in an enterprise data center, it's not uncommon to see dielectric waveguide taps and packet brokers and inline inspection devices and all these kinds of things. And in the cloud, it's a little harder to do that because you don't control that physical infrastructure. So what we do is we give you software tools that are built into the infrastructure that allow you to do that. Everything from key management and storage, which StorReduce happens to be fully integrated with, to ingest traffic for, if you're using one of our WAF products, for example, we can be that shield between you and the outside world from your application for denial of service purposes or for malicious attack purposes. We give you great audit trails. We give you federation options for different identity systems. And all of these things are available, but you have to sometimes do the integration. Now, if you sort of divide up, what are we responsible for and what is the customer responsible for? AWS says we'll take care of, the physical component. We make sure that, in situations like, meltdown and heartbleed, that we take care of the, underlying infrastructure. But then when you look above that, the customer section, it feels like a longer bullet list. And so a lot of times that can be intimidating. And so one of the ways to actually reduce that list is to look at partner products that follow our best practices like StorReduce, and they can actually do a lot of that for you. So for example, the server-side encryption, the client-side encryption, the data integrity authentication, network traffic protection, all of these things are actually handled already by StorReduce. And so if you cross those three off the list, now your bullet list is a lot smaller. It's just one less thing that you have to worry about. So that's another advantage to going with a partner product. A lot of people have compliance requirements. This slide used to be much smaller. It used to be like 12 icons. There's so many regulations, there's so many frameworks and certifications these days that we don't even use the icons anymore. We just tell you where they are. So if there's anything on here that's applicable to you, the things that you would probably want to understand are, is there something that I, need to turn on? So for example, if you have some sort of SEC rule, 17A4F, for example, then you need to be able to have a worm type semantic. So, if there's one of these things that's applicable to you, you'll know it most likely, and you know what the effect is. But what you may not know is, well, how do I do that in the cloud? So the good news is that if you see what's applicable to you on this list, we have documentation that can help. Solution architects that can help. We have a whole compliance team that can help with the conversation as well. And so I hope that there's nothing missing from this. If there is, please pipe up in the question, and I'll make a note to update our slide or make sure that it's being worked on. So without any further ado, one more slide. These days the cloud is sort of a household concept. A lot of these icons that are up here are household names, and these logos. It's very rare these days to find a workload that isn't in the cloud at like a Fortune 500 company. It's very rare to find a Fortune 500 company that doesn't have a cloud workload. Now, it may not be everything. It may not be, if it's a bank, it may not be their core banking software, or maybe they still run Solaris on Spark and Oracle on-prem for their OLTP workload or something like that. But by and large, companies aren't really building new data centers anymore. They're looking at how do they actually shut down their financial liabilities, like their secondary and tertiary data centers. And so if you find yourself in a similar boat to all of these guys, I think you'll find success in the cloud as well. So with that, I would like to introduce Hugh Imberson, CTO of StorReduce. Hugh, take it away.
Thank you, Isaiah. My name is Hugh Imberson. I'm the CTO of StorReduce. And StorReduce is a scale-out software-defined virtualization layer for object stores like Amazon S3. So StorReduce has a number of services within it, and the services are things like it can deduplicate data before it lands in or is transferred to S3. It can do deduplicated replication of data between Amazon regions or between dissimilar object stores. And it can do near instantaneous copy-on-write clones of data stored in object stores. That's kind of like NetApp volume clone for S3. But the service that we're going to be talking about most today is deduplication. And just in case you're not familiar with that term, deduplication is a data compression technique for eliminating duplicate copies of repeating data. Unlike other lossless compression techniques, which can compress data by factors of 2 or 3 to 1, deduplication can compress certain workloads by factors of 10 to 1 or 30 to 1 or 50 to 1 or more. The workloads that deduplicate the best are backup workloads, which is what we're here to talk about today. And in particular, StorReduce allows you to replace your purpose-built backup appliances on-prem with Amazon S3 and save up to 80%. We can also replace tape backups and save up to 60%, depending on the assumptions. But the best part of this is that you don't actually need to replace your backup application. You can install StorReduce in AWS or on-premises with your existing backup application and just send your backups and archives into Amazon S3. By the way, we're excited to mention that StorReduce was recently named a Gartner Cool Vendor in Storage Technologies for 2018. Whoops, back one. Okay. In addition to helping you save money and increase the availability and durability of your data by storing it in the cloud, StorReduce also allows you to use cloud services to learn something from your backup data. Previously, backup stored in backup appliances or on tape were only good for one thing, recovery. But when you think about it, an organization's backups are the one place where all the important data in the organization comes together. So it's the one place that's the easiest to learn something from that data. Our StorReduce Insight product allows you to take your backup data and analyze it with one or more scalable cloud services. For instance, you can run your data through a malware or antivirus service to detect malware in your backups. You can do this periodically to detect strains of malware that have only recently been discovered and that may have been lurking in your systems for some time. And you can trace back malware infections back to the point where they entered your network, effectively finding the patient zero in your network. That's the original failure in your security systems that allowed that malware into your network. You can search inside some or all of your documents. Imagine being able to find all of the documents produced by your legal department that mention the name XYZ Inc. if you're in some sort of litigation. You don't have to rely on the documents being named or filed correctly. You can and then finding them in your backup catalog. You can just find them by searching for words or phrases in the documents. You could also run sentiment analysis across your documents produced by your customer services department and see if the document's tone is angry or happy. Then you can educate the customer service reps who are sending out angry sounding documents to your customers. And this is all built on a very simple plugin architecture, so you can easily integrate with new cloud services in only a few minutes. And the list of services that we can integrate with is just starting, because there are new services being invented every month that we can integrate with. I'll be showing a demo of this capability later. So this is how StorReduce works. StorReduce is deployed as software in an AMI in the cloud, or a VM, or a Docker container on premises. In general, you want to deploy StorReduce as close to the source of data as possible, because StorReduce doesn't just decrease the cost of storing your data in S3, it also decreases the cost of transferring the data into S3 across a WAN. Data comes into StorReduce from backup applications or file system gateways or other S3 applications on the left-hand side. The data comes in over the S3 API protocol, and that's the same protocol that you use to store data into Amazon S3. The data is deduplicated in memory, in line at high speed in the StorReduce server, and that deduplicated data, which is usually much smaller, is written into Amazon S3 on the right. Technically, the deduplication scheme that StorReduce uses is a variable block length deduplication scheme, and the deduplication ratios that it achieves are usually within 1 to 2% of the best appliances, sometimes a little bit better, sometimes a little bit worse. When the deduplicated data is written into S3, all the metadata that is needed to reconstruct the original data stream is also written into S3. This means that if the StorReduce server is ever lost, let's say it burns up in a fire, all of your data is stored in Amazon S3 across at least 3 separate availability zones with 11 nines of durability. To recover, all you need to do is get another StorReduce server, point it at the same bucket in S3, and you can recover every single bit of data that was previously stored by StorReduce right up until the millisecond that the server burned down. StorReduce runs on commodity x86 hardware, and the only hardware requirement that it has is that it needs a small amount of SSD, which is used as a metadata cache. The amount of SSD required is 0.1% to 0.2% of the volume of pre-deduplicated data. So if you're storing 1 petabyte of data before dedupe, then you need about 1 to 2 terabytes of SSD for StorReduce. So StorReduce is fast. A single StorReduce server can process up to 2.5 gigabytes a second of deduplicated throughput. A cluster of servers can process much, much more, depending on the number of servers in the cluster. StorReduce is stateless. If no data is ever lost if you lose a StorReduce server. It's all stored securely in S3. It's scalable. We can cluster servers together so that you get the throughput you need, and you can scale it up and down as you need to. It's software defined. You can deploy a cluster in Amazon in minutes or on premises in less than 1 hour. And it's enterprise ready. StorReduce clusters are highly available and have a number of other enterprise features like deduplicated region-to-region replication, hybrid cloud configurations, and more. And finally, because data is stored in the cloud, security is very important. So StorReduce is secure. Data coming in and out of StorReduce, going into S3, is encrypted in flight using TLS, what was used to be called SSL. Data can also be encrypted using AES 256, but look before it leaves StorReduce, so that when it lands in S3, it's already encrypted. And those encryption keys can be stored in Amazon's KMS service or in a KMIP-compatible key management or hardware security module on premises. And this is how we construct a StorReduce cluster. The cluster is made out of any odd number of StorReduce servers running on commodity x86 physical or virtual hardware. A cluster gives you higher throughput than a single server. The throughput of the cluster scales linearly as you add nodes, so you can grow or shrink your cluster over time as your throughput needs change. It gives you high availability. A cluster can survive the loss of one or two servers and keep working. StorReduce clusters can be configured so that they actually have no single points of failure. In contrast, backup appliances usually have one or more single points of failure. The cluster has a single namespace, so any bit of data stored in the cluster can be accessed from any node in the cluster. With backup appliances again, you can scale the backup appliance up to a certain point. But at that point, you'll need to buy another appliance. And then you're going to end up with silos of data that you need to manage. You'll be shuffling backups from one silo to another and managing the capacity across all of these silos. With StorReduce, you can just add more servers to the cluster as your needs grow. StorReduce is also a single deduplication pool. The deduplication pool is spread across the entire cluster so that you only ever store one copy of each block of data. So StorReduce can be a single deduplication target for your data center, or for a cluster of data centers, or an Amazon region. This is a StorReduce cluster operating in Amazon EC2. You can run StorReduce either on-prem or in EC2. This one was in EC2. The cluster has 15 nodes running on C3 8x large instances, and it's storing into Amazon S3. When we took the snapshot, the cluster was storing almost 8.3 petabytes of data, which are deduplicated down to 237 terabytes, which is a reduction ratio of 97% or 30 to 1. The cluster was ingesting data at almost 14 gigabytes a second, which is about 3/4 of a petabyte per day, and it could recover at almost 8 gigabytes a second. And that recovery speed doesn't slow down as the system fills up, because it's virtually impossible to fill up S3. This is the StorReduce value proposition. Basically, the idea is you can replace your backup appliances, like IDT did, or your tape with StorReduce, and then back up faster and reduce the cost of your backup storage by storing into Amazon S3. You can also get an offsite backup with no single points of failure, no silos, that scales as your business scales. And you can use cloud services to extract extra value from that data. And you can get started in less than 1 hour because you don't actually need to change your backup application. StorReduce works with most major backup applications. We're a Veritas technology partner, and StorReduce has been an option in the NetBackup console since NetBackup 7.7. We also work well behind Commvault and Oracle RMAN, and there are many other backup applications that have an S3 interface. If your backup application can't target S3, then we can use a CIFS or an FS gateway, like the QStar ASM, to bridge that gap. Right. We have TCO models that can help you determine the difference in the total cost of ownership of StorReduce and AWS versus a backup appliance. This is the output of one of those models where we're looking at storing 10 petabytes of pre-deduplication data. That's 1 petabyte backed up 10 times, or 100 terabytes backed up 100 times. And we're assuming a deduplication ratio of 10 to 1, which is a very conservative deduplication ratio. And the storage that we're using is Amazon's S3IA, which is a layer that's specially designed for storing backups. It's cheaper to operate than Amazon S3, and it's just as durable. As you can see, over 5 years, we can save about 72%, or $5 million, over the total cost of operating these systems. And now I'd like to invite you to answer a quick audience poll. And the question here is, what services would you use on your backups that have been moved into S3 with StorReduce? And this is harking back to the bit where we talked about how you can use services to search inside, or to learn something from your data in Amazon S3.
Hey, Hugh, is there, when you talk with customers about, what people want to find inside their backups, when you say PII detection, would that relate to things like GDPR or SOX, or, can you talk maybe a little bit about that kind of use case just while people are filling out the poll?
Yeah, absolutely. I mean, for compliance reasons, companies want to make sure that personally identifiable information is not turning up in places that it shouldn't. So, if your customer service department's got credit card numbers, that's probably okay. But engineering probably shouldn't have real people's data. And it's also very important for GDPR, because the big thing there is the right to be forgotten. And the first thing that you need to do when you're trying to forget someone is find out where all the data that you have about them is stored.
So if you don't have a mechanism for easily finding that, you don't have a way to actually purge it. That's a great point. Yeah.
Absolutely.
And now you mentioned things like credit card numbers. What are some other personally identifiable information sort of attributes? Like I would imagine a social security number, but are there certain kind of documents that you would probably more likely find these things on? Is there some kind of metadata stuff that you can put at play?
Yes, there's driver's license numbers, there's addresses, there's passport numbers, photos, things like that. Those can all be found using these services.
Photos I hadn't actually considered. Yeah. So I mean, in that scenario, do you need to do some sort of analysis on the photo?
Yes, I mean, there are products out there, there are services out there that will take a look at a photo, and you
Right.
can extract those photos out of StorReduce, pipe them to that service, and then it will tell you what's in the photo. If the photo just contains a picture of a person, there's a really good chance it's a passport photo.
Oh, you make a great point. If it's like a single headshot, yeah, totally.
Yeah.
Or a resume, like in Europe, it's super common to have your headshot on your resume. Yeah, interesting. Okay, cool.
Oh, great. And it looks like the results are in from the poll. Thank you for everyone who voted. And it looks like the winner here is search inside the text of all your documents, with AI and PII detection coming up second and third. Thank you to everyone who voted there. And with that, I'd like to hand over to David Wartell. Over to you, David.
All right, thank you. Fantastic presentation, Hugh. My name is David Wartell. I'm currently an executive officer at IDT, and I've been there for about a year. You may have used products from brands and companies I've co-founded in the past, like Idera or R1Soft. Now, a little bit about IDT. We've got over 1,000 employees, somewhere north of $1 billion in revenue, and IDT is in the business of using financial services and communication services to connect people in ethnic communities in the United States with their friends and family around the world. IDT is also a publicly traded company, and because of our services in global telecommunications and financial services, we are subject to a lot of regulatory and compliance requirements. Now, IDT has a hybrid infrastructure. We have a variety of data centers around the world, and those are connected to AWS via Direct Connect. Now, when I got to IDT about a year ago, I was here about a month, and I got a very large purchase order for almost 7 figures for some quantum dedupe appliances, and I wanted to look into it before I was approved those. And the next day, a very nervous storage administrator marched into my office saying how we had to buy this right away. And it turned out there was nothing wrong with the appliances that we had. They had plenty of capacity. They were operating normally. What the deal was is that they were 4 or 5 years old, and we were caught in this deal where the maintenance costs skyrocketed. It's something like a multiple of 4 or 5x. And I felt like buying this hardware was working with a loan shark. So I said, okay, we're not going to do that anymore. And so I simply Googled AWS S3 and dedupe, and I found StorReduce. Now, our backup landscape before StorReduce, we've got about a petabyte of on-premise data in our various data centers. And that backup data, sits in pretty typical things you might expect: VMware farms, NetApp filers, and we've got a large Oracle Exadata infrastructure that I unfortunately inherited. And that data is backed up using Veritas NetBackup and Oracle RMAN, and was stored in a variety of redundant dedupe appliances. Now, what really was the driver for us to look at other solutions and going to the cloud? The initial driver was cost, and we didn't want to rebuy hardware when there was nothing wrong with it. But then as I looked into it further, IDT, had a pretty typical offsite backup strategy from maybe a decade ago with tape robots, where the armored car comes and picks up the tapes. And so I was really interested in taking offsite backups to the cloud. Also, like a lot of companies, we're moving more and more workloads to the cloud. And so the amount of data that we have, to back up is not just kind of growing linearly. We might get some growth as the business grows, but we're also moving workloads. So the idea of having backups and backup storage that was elastic was really quite appealing to us. And the other thing is, like the first presenter said, StorReduce kind of fits this Unix philosophy of a really good point solution that solves the pain point. We did bake-offs with other vendors. We talked to Pure Storage. We talked to a number of different backup vendors. And they all could eventually get data to S3 in the cloud, but they required storing a complete full copy of the data locally. And they also required us to replace really our entire backup infrastructure, which would have been a very large project, and we weren't motivated to do. And I really didn't want to have all these spinning disks storing a copy here. I wanted to get it all off to the cloud. And StorReduce, just allowed it to be inserted into our existing environment, because it presents this S3 interface to all of our backup software. Any backup product we use, virtually all of them will eventually write to an S3 API, and so it just plugged right in. And so this is what our backup landscape looks like now. Still the usual suspects of Veritas NetBackup and Oracle RMAN, but we just simply point them at this S3 API that StorReduce presents. And StorReduce just has some servers that scale out with a local cache, and all the data is deduped before it's sent across our Direct Connect. And when we started, some of the folks at IDT were really concerned about capacity in our Direct Connect, and it turned out that with the deduplication, it was absorbed and hardly noticed, even with the amount of data. And after it goes into the Direct Connect, we have these Linux EC2 instances that auto scale, and they simply serve as a Linux NAT proxy, and that allows us to connect to S3 through our VPC and Direct Connect without going public to the internet. And one question I've got asked, and we talked a lot about this in our organization, is what do we do with these old quantum dedupe appliances? And we really didn't want them to go to waste. We thought about maybe using them to back up some non-production infrastructure, maybe even just treating them as RAID arrays for non-production storage. And then something curious happened. A battery failed on one of the controllers on these appliances. And this is just kind of the RAID controller backup battery. It's like a camcorder battery. And I saw a bill to replace it for $5,000. And I said, that's it, we've had enough. And we put the quantum dedupe appliances out to pasture. So just to summarize, we got offsite backups, and we had a significant financial savings. We got out of this maintenance scheme and kind of loan sharking, like I like to call it, that some of the storage vendors do. And now our backup storage can scale up and down based on our needs, and it's really quite flexible. And we were able to check the box on all the various regulatory and compliance standards that we have. Okay, now I'm going to pass it off to Hugh for a live demo. Thank you.
Before I start the demo, I just want to set the scene, just to remind you of what's going on. So in this demo, there is a number of systems that are being backed up by backup application into a StorReduce cluster, and then that data is being stored into Amazon S3. And the question that we're going to ask is, how do we know that these systems don't contain malware? How do we know that our other security systems are working? And how do we trace the malware back to the point in time when it entered the network? How do we find patient zero within our network? And so StorReduce Insight solves this. Insight's an add-on to the StorReduce system, and this is how it works. Every night, or more frequently, you back up all your systems via a backup application, and you store them via StorReduce into Amazon S3. StorReduce deduplicates those backups, stores them into S3. And then StorReduce Insight scans your backups. It extracts all the data and the metadata out of the backup tar files. And the data is streamed into a malware detection service, where it's scanned for viruses, worms, or ransomware. As an aside, StorReduce Insight can send the data to any system that can analyze that data and derive some knowledge from it. This demo here is about malware, but you can use any service that you select to get some benefit out of StorReduce Insight. You can use data loss prevention services or analytics services, sentiment analysis, or as it appears everyone's excited about, you can search inside your data. And we have demos of these other services in the StorReduce YouTube channel if you want to take a look later. Now, when the malware detection service is finished with a piece of data, it returns the malware results, and we store those along with the metadata into our Elasticsearch cluster. And then from that, we can generate a report that tells us what's going on, what's been detected, or if we're all clean. And we can tell from this, in this report, what malware is found, where it was found, when the infection happened, most likely, and even potentially who was using the system when the infection happened. And now we'll get into the demo. So this is a NetBackup console running on a Windows server. And we've used this backup policy. I don't know if you're familiar with NetBackup, but it has a policy that says take backups of these folders, store them via this storage unit, which is a StorReduce storage unit, into the cloud. If we switch over to StorReduce, we can see here that the StorReduce dashboard. This is where the data is stored in StorReduce. And here we can see at one of the backups that NetBackup has done into the system. And this is just a very small system. As you've seen before, we can have systems that have petabytes of data, not gigabytes. And you can also see here that we've deduplicated this data and got a very nice deduplication ratio for it. Now, if we switch over to the Insight dashboard, okay, Reload. Just try that again. Okay. If we switch over to the Insight dashboard, then we can treat this a bit like Google for our backups. We can go and search within the backups to find out information about them. So this is a search query that finds the data about a particular backup run that we did one night. And here we can see all of the files that were in that backup. And we can see that the virus scanner has actually gone and annotated these files to tell you whether there was a virus in them. And so this one has got a virus, apparently. So if we click on that, we can find a little bit more information. We can see that it's a DLL, that it's part of Microsoft Silverlight, that it was backed up from this machine at this time. And if we scroll down here, we can see the information that the virus scanner found out about the file. It's infected. This is the malware that was detected. This is the virus scanner that detected that malware and the date and time that that happened. Now we can go back to the search results and we can do some more searches. For instance, that found just some of our backups. Let's go and have a look and see what all of the infected files within this backup. So as you can see here, we've got 4 files that were infected. We can also go and find all of the files that were not infected in the backup. And there we can see everything that was not infected. And finally, just as a backstop, we can also see all the files that we didn't scan. And this is good because it's showing no results here. So if your virus scanner had had a failure or something like that, we would see some of the files had not been scanned. And that would indicate that you might have a problem.
And you can submit this as part of an API query to StorReduce, right? To the StorReduce Insight product. So you could have an alert based on this.
Absolutely, yes. I mean, the StorReduce Insight has a simple, user interface, but all of the data is actually stored in Elasticsearch. So you can use any tool that understands Elasticsearch to search or alert on this kind of data. For instance, you could use Elastic Kibana to do that.
So I could, so as a customer, as a user, I could actually have a Lambda, one of our interval based Lambda queries, query this Elasticsearch interface, and tell me what my liability is at any given moment, and throw that into like CloudWatch, for example, and I could know whether or not I was actually getting all my data scanned.
Absolutely, yes.
Wow, that's great.
Yeah, and just because in the poll Search Inside came up, this is just a demo of Search Inside. We also backed up a bunch of books from Gutenberg, and just by searching for a word, we can find all of the books that contain that word, and we can even drill down into them and find out more information about the book that contained that word, or even download the book. But that could be a document, that was generated by your legal department. And that's it for the demo. I'll hand it over back to Isaiah for a Q&A.
Awesome. Thank you so much. Thank you, David, for giving us your story. At Amazon, we believe that customer stories are the most impactful. We got a bunch of questions, so I want to start with John's question, and this is a question about importing existing data sets. So let's say that you have an S3 bucket that you've already put data in. What's the best way to migrate that data that's already in S3 into StorReduce? Hugh, I think you're probably the right person to answer that question.
Yeah, so the best way right now is to just use a script using, say, the Amazon S3 CLI, which is pretty much sort of a Swiss Army knife for dealing with S3. That can pull data out of one bucket and then push it into a StorReduce bucket very easily, and you can write a script in a couple of lines of shell script or bash file, and just set that running, and it will just run until it completions.
And that those are idempotent, right? In the sense that, you know, if you do have failures and you start it again, the synchronization will cause data that has already been put up to not be re-put. Is that's a good way to say it?
Absolutely, yes.
So you could run, theoretically, you could probably run in parallel lots of those synchronization jobs and speed it up even more. Keep your pipe full. What do people
Yes.
typically do about? I mean, you know, let's say if you do have a stack of maybe you've got an instance and an app and an S3 bucket. Is it common for applications that know how to talk to S3? Is it common for them to know how to talk to custom endpoints?
Yes, most applications are designed to talk to different S3 endpoints, because there are a lot of other systems out there that implement the S3 protocol.
I guess that's the curse of success, right? Is it that you get duplicated and you can dedupe it with StorReduce. What in those environments where you see a lot of customers, what types of workloads do you typically see? You'd said backup, but are there verticals, like industry verticals, that are a good or, you know, better or worse fit? I mean, can you talk about, you know, if I'm a customer, how do I know if I'm big enough to need this, or how do I know if I'm too big for it? I mean, you know, it sounds like the limits of the elasticity of the product are limited basically by S3, but what about on the other end of the spectrum? You know, when should I start to invest in dedupe if I think that I'm going to have a lot of data?
You should probably start to invest when you've got something on the order of a few hundred terabytes of data being backed up. And so that sounds like a lot of data, but it's, you know, 100 terabytes is 10 terabytes backed up 10 times. So,
Right,
you know, backup tends to multiply things out very quickly.
right, and that's one of the key differentiators actually between a backup and archive. Right, in archive you've got
Yeah.
one copy of it. In backup, it's totally normal to have, you know, 50 copies in a year. Right.
Absolutely, yeah. Archives are curated, whereas, you know, backups are well, they're point-in-time snapshots of your enterprise.
David, I want to ask you some real world questions. When you were looking at the dedupe ratio of StorReduce and the dedupe ratio of your on-prem stuff, how soon did you find like equilibrium there between what you had and you know and what you implemented? You know, was it immediate? Did it take, you know, a week? I mean, where in the process were you able to say, okay, you know, our ROI is going to be met, we know at 100%?
We knew right away. I think the only thing that took some time was getting different backup loads in there. For example, our RMAN backup set dedupes very differently from VMware backups. But generally, we found roughly the same dedupe ratio as the quantum appliances. So depending on the data set, it fell somewhere in the range of about 20 to 1 and 30 to 1.
Got it. Okay, that's fantastic. And everybody knows what you did with your old dedupe appliances, thanks to the office space photo. Can you talk about your direct connect setup a little bit? I mean, you'd said that people were worried about, you know, saturating it. What kind of connectivity did you have? I mean, was it like a gig or 10 gig? And you know, how did your, you know, pushing the dedupe workload over it impact your utilization?
Good, great question. I hope you got a laugh out of that. My next target is our Oracle Exadata. Would really like to take those out and bash them. But the AWS Direct Connect, we've got two 10 gig links to AWS.
Wow,
And yeah, and so in your previous question, you know, you were talking about what drives the need for dedupe, and so one factor is really network. And so if, you know, depending on whether you've got a direct connect or you're going over the public internet, a lot of people really aren't excited about having this massive increase in workload at certain times of the day and the bandwidth, and so, you know, dedupe is really a great way to address that.
I mean, and even as a company with expertise and presumably sway in the telecom world, you know, you guys were concerned about bandwidth. I can't imagine, you know, how normal customers would feel. People who struggle to get, you know, a gig connection maybe in their location, and you guys had 20 gig, and you were still concerned about saturation. So when you look at the cost of doing that network upgrade, obviously that's a big commitment. If you didn't have dedupe, and you were going to push all this stuff to the cloud, you would need to get a much larger set of contracts over a multi-year period of time. Was that factored into your sort of TCO and ROI calculations?
Not extensively, because some of those options were looked at by the team, but I really didn't take them seriously. But there was some discussion around, hey, we may need to get a dedicated link just to run backups over, so we don't affect our quality of service, or we need to look at layer 3 quality of service to kind of segment the data. Yeah, and it really, as soon as we ran the dedupe, it wasn't an issue at all.
That's great. It's amazing actually, because it's like one of those things where you'll throw the pebble in the pond and it ripples out. When you make these decisions, you don't know how things are going to get implemented. So when you do your POC, you learn a lot. How long did you guys give yourselves to do the POC in your decision-making process?
Really, about 60 days probably. And part of what I'm doing at IDT is kind of transforming a culture, and so soon at some point you'll see the word telecom disappear from our website, and we're a technology company. But a lot of the people have been here for well over a decade, and so as I start to kind of challenge the organization to do things differently, they kind of look at this and they say, oh my gosh, but the costs are going to skyrocket for S3, and we're going to need more network bandwidth. But once they got comfortable with the technology and saw the results, then everything shifted pretty quickly. But honestly, my biggest challenge was kind of the mindset of some of the people on the team that had been doing things a certain way for a long time. That was really the biggest roadblock.
And were they set at ease at all by the fact that you weren't actually changing your backup apps?
Well, yeah, sure. Nobody's excited about completely ripping and replacing a backup architecture. And just a couple weeks ago, I saw, an update on how StorReduce is going, and now the team has decided, well, geez, we have these tape backups that we store, I think, for about a decade due to some regulatory requirements. Maybe we can just get rid of the tapes and just start storing those in S3 or Glacier. So.
That's really funny. So it's like something that started out as backup, not long-term archive, for example, is going to expand in scope. I would imagine that anything that you're touching S3 for, even if it's applications, could benefit from the same thing. I mean, once you start to throw data into a pool that can be deduped, you don't even know how. I mean, it's at the point that you got multiple projects in scope. Probably anything you put in there could be deduped.
Yeah, generally anything except something that comes across encrypted before it hits StorReduce. But of course, StorReduce can do the encryption for you.
You just made a great point, and Hugh, I'd like to ask you a question about that. So, Hugh, can you talk a little bit about key management and encryption? Because a lot of times, backup applications will do this for customers. Can you maybe talk about some best practices, what customers should do, how they should think, what kind of questions they should ask themselves for when they know that they want their data to be secure in the backup, but they don't want to stump the dedupe engine?
Yeah, sure. So, the first thing is that encryption kills compression and deduplication. So, you have to do your encryption after you've done your dedupe or compression. But the other thing that the people, I guess, don't think about as much when they're thinking about encryption is they're thinking, oh, let's just go and encrypt everything with AES 256. The important thing to think about is where you store your keys, because the keys are literally the keys, and you want to be very careful about where the keys are stored. And we decided very early on that was not a business that we wanted to be in. It's very difficult, and it's very, very hard to get right, and it's a target for hackers and everything. So it's best to leave that to the professionals in that particular space. So we integrate with Amazon's KMS service, which stores all of its keys and hardware security modules in the cloud, I believe. And so you get your own little private area in a hardware security module, because those things are expensive, and you can, Amazon takes care of managing the keys, of making sure that no one, not even Amazon, can get to them. But if that's not enough for you, you can also integrate with a key management system or a hardware security module on premises. As long as it supports, there's a protocol called KMIP, which we can use, and that will then be used to store the keys. So these things are, they're tested by, the government and the military and everyone else to make sure that they're storing your keys successfully in a way that no one can get to those keys unless they have the proper access rights.
So you talked earlier about, all the TLS stuff, and if you're using Amazon KMS, I just happen to know that you follow all of our best practices. So you generate the one-time keys with the objects, and then you support, encryption policy on the bucket. If I'm a customer and I want to use both your integration with KMS, but I also want to use, I want to have control ultimately over the keys. What should I do? Should I use the customer master key model inside of Amazon KMS to import my on-prem keys?
Yes, I mean, it's going to depend very much on what your security people say, but that is certainly, I think, a very good option. And we have customers in quite sensitive areas that are using that exact same option.
Okay, gotcha. Right on. How about when I want to use the metadata functionality? You got a great question around that. You mentioned, in your demo that you were using ClamAV. Can I use anything? I mean, like if I have my own, maybe like a, GPU powered machine learning type thing, can I ingest data like with literally anything? Is this an open framework for me to be able to inspect stuff, or am I limited to sort of things that maybe you guys have already proofed out?
I know there's a very simple plugin architecture that allows you to integrate with anything that has some sort of an API. Preferably some nice scalable RESTful type API, but anything that has an API, as long as it can take a stream of data and then tell you something about that stream of data. So yeah, you could do machine learning, or you can integrate with any security product that supports the ICAP protocol.
Gotcha. Oh, that's an established protocol. I gotcha. Okay.
Yes.
And then the last question, because we're at time, you talked about there being a local cache. Obviously, if I'm deploying on-prem, I need to manage that hardware, maybe as local cache that's available to my Docker instances that is stateless, or VMware or something like that. Do I need to size that local cache based, what do I need to know in order to size that local cache? Maybe is a good question. So you talked about the size of the memory that was required for the cluster as being a range of 0.1 to 0.2% of the data set that you were going to store. But what about cache? How should I approach sizing that?
Yeah, so we have another product. It's called Hybrid Accelerator, which we didn't get to talk about today. But yes, it allows you to manage a local cache. And the way you want to think about that is you want to have enough data stored there to satisfy your most frequent restores. So that it's going to be, probably 90% of all restores happen within probably 15 to 30 days with after the file was backed up, and so you probably want to be looking at sizing the cache so that it can store 15 to 30 days worth of deduplicated backups. So take the amount of stuff that you back up in 15 days and then divide that by, say, 10 for your deduplication ratio. And that gives you a very rough answer to that question.
Interesting. So the same logic that I would previously have applied to maybe, how much local disk I was going to have for a disk-to-disk type backup application, I can apply a similar sort of logic to understanding how much cache I need for StorReduce.
Yes, that's
Okay.
correct.
That's great. So I get to reuse all of my existing knowledge and
Yeah.
take advantage of new technology. Thank you so much, Hugh. Thank you so much, David. And most importantly, thank you so much, attendees, because without our audience, we're just talking to each other. Please remember that if you stay connected, that you can complete a brief survey at the conclusion of the webinar. But if not, in 2 to 3 days, you'll get a link to the SlideShare and YouTube links for the recordings. We look forward to supporting you in your current and future projects. Thank you again. Have a great day and a great rest of the week.